Today I'll be estimating a simple panel data analysis. And as you know, I've already loaded my data integrator, and as the previous videos shows you how you can load your data integrator, I hope you have done same. You have also loaded your data integrator. Without wasting much time, we can move on to perform the um, OLS for the panel, which is the ordinary square for panel, but the ordinary square for panel data stands for the pool model in Gretel. So first we have GDP, we have trade openness, we have FDI. We are going to do it for using GDP as the dependent variable. So without wasting my time, click on model, ordinary squares, and we have to put GDP as the dependent variable, and as I can also show you like this, you can also select this one and put them here. Okay, click on OK once you are set. So when you click on OK, look, the coefficient for me here is really big because I don't know, maybe I might have to convert GDP to log and leave the rest of the variables as levels. So first of all, let me just close this one again. Let's convert GDP to log, add log of selected variable, then go to model. So I'll put this one here, and also I'll click on OK. Just click on OK once you're done. So I'll click on OK. You can see it has reduced the coefficient, which were very bigger. So once you have this, you can just copy your model. This is the pool model, please don't forget. This is the pool model. I will paste here and I will add up borders to it, and also this same thing here. So you have, this is the constant, let me add it, constant, and we have FDI. The trade represents trade openness, and then FDI is foreign direct investment. As you can see here, this shows that the coefficient of the constant is statistically significant at 1%, around 1%, and it has a positive coefficient. Trade openness has a negative coefficient and is statistically significant, and FDI has a positive coefficient, statistically significant. This implies that if trade openness change or a percentage change in trade openness leads to a negative or a decrease, let's say a decrease in GDP. When FDI changes or increases, it increases GDP by this coefficient. And as you can see here, it means that trade openness has a negative effect on GDP in the selected countries, and FDI has a positive influence in the selected countries' economies. So before we move on, I don't need this one, let me delete this one. Before we move on, we have to test and see if the pool model is sufficient to be used as our final model. And there's a test called panel specification test, which is performed to assess whether the pool model is sufficient over the fixed and random effect model. And as you can see from this table, let me push the table up a bit. That is the panel model specification. So at this point, we have three tests under this panel specification test. We have the F test, which compares the pool with the fixed effect model. We have the brush pattern, which compares the pool with the random effect model, and then we have the Haussmann test, which compares the random effect model with the fixed effect model. And a lower p-value count against the pool model if the F test output the p-value shows that it's less than 5%, it means that the pool model is not sufficient. Then we will go for the fixed effect model. The same thing goes to the brush pattern compares the random effect with the pool model. When the p-value is lower, it means that the pool model is not sufficient. Then we need to go for the random effect model. And this one compares the random effect model with the fixed effect model, and a lower p-value goes against the random effect model, and we need to stick with the fixed effects. So without wasting much time, we need to click on test. When you go to test, you can see panel specification here. Click on it, and as you can see here, look, it's stating here joint test, that is the F test. And as you can see here, there's a p-value here. This p-value is around 1%. It's even lower than 1%, so we can put 0 here. And this indicates that the pool model is not sufficient because it counts against the pool model, and it is in favor of as it has stated here, it is in favor of the fixed effect model. So here we reject the hypothesis that the pool model is sufficient. We reject it. So we are rejecting it. That's your conclusion. We need to compare the brush pattern. Look here. So it is comparing the brush pattern is comparing the pool model with the alternative model, which is the random effect model. And look at the p-value. The p-value is significant, around 1%. So we can put 0 here, and it is rejected because the pool is not sufficient. So we need to go to the Haussmann test. You can see the p-value here, which is the Haussmann test, which is comparing the random effect model with the fixed effect model. So this means that the random effect model is adequate because the p-value is greater than 5%. And as you can see here, majority carries the vote because brush pattern test, which assesses the adequacy of the pool model against the random effect model, state that the random effect model is adequate and is the most appropriate to be used. And here too, this is comparing this one, and it's showing that the random is adequate to be used. So it says that the random has the majority, and we need to stick with the random model estimation. And this states that the random effect model is going to be our final model in this regards. So we can close this one as we are done with the panel specification test. So we need to go again and re-estimate the model. And so we can go to panel, and as you can see here, we have fixed effect model or random. So we need to estimate for the random. But before going that, we can also estimate for the fixed, even though we know that the fixed is not the final model. So let's put GDP here, and then it's already selected fixed. So we can click on OK. And this is our random, this is our fixed effect. So this is our fixed effect model. And as you can see here, we need this part. We need to copy everything and paste it here. So once we have this, we can beautify it. And the coefficients doesn't change. You can see that trade openness is still negative, FDI is positive, and the constant is positive. So we can, and as it has been interpreted already, you can state that trade openness leads to a reduction in GDP, and FDI increased GDP in the selected countries. So we can also move on to the estimate the random effect model by going down. This is just an intercept, which is explain this place is explain the intercept, and I will try to estimate that one for you as well. So I'll first of all delete this one, and let me try to explain how you can estimate using the various countries intercept. Before I know the random effect is going to be our final model, but okay, let's estimate the random effect before we move on. So we can close this one, we can go to model again, go to panel, and at panel here you need to put your dependent variable, and you need to select random. So once you select this thing, click on OK. So once you click on OK, you can see that the coefficient has not changed, and you can also select these ones here. So you select this one and you can paste it. So this is our random effect model. This is our random effect model. This is our random effect model, and you can see the coefficients did not really change much, even though there might be slight difference, but it did not change much. So once we have our random effect model, we can move on to the next step. This is our random effect model. This is going to be our last and our final model for whatever test, whatever estimation we are going to do for the panel data. I'll delete this one and put random. So once we have the random model estimated, we can move on. I would like to show you something different, which is about trying to know the intercept for each of the respective countries. First of all, I'll close this one. You go to model, you go to ordinary least square, you put okay, before you can go here, let me just try to show you something. You can click on cancel, go to countries. You know we have the countries. Number one, country 1 is Ghana, country 2 is Uganda, country 3 is Morocco. So let's see, we know let's put this thing at the back of our mind. Kenya is the last country, so we can demify the countries. You just have to right click, and then you can see this. You can see demify. So I'll click this and use the first one, encode all variables. Click on OK. It has been demified, and you can see here country 1 the same thing. So let's go to the estimation, because at this point we want to know the intercept for the various countries, and what we are going to do is that we need to estimate it through the ordinary least square in order to know the intercept for the respective countries. So here, if we are going to we are at ordinary least square, we know country 1 is Ghana, country 2 Morocco, blah blah blah. So we continue. We put this one here, the dependent variable there. We have these variables. Since we want to know the intercept, we cannot include the constant, because the intercept sound for the constant. So we need to know the intercept for all the countries. Let's see what will happen. For instance, I'm going to do this one by including the constant. If I include the constant here, it's going to cause either a high multicollinearity. Let's see what happens. So I'll click on OK. As you can see, excluding the constant, p-value was higher for this. You can see country 4. So country 4 will not become statistically significant, and it will change in negative. but you can see due to exact collinearity, look at on top here. So what you need to do is that since you are estimating for the intercept, you don't need to include the constant. So let's go back. I'll close this one, go here, go to ordinary least square again. I'll exclude the constant and then put GDP here and click on OK. Now you can see everything has popped up. Good. And we just need to copy this one and paste it. Copy and click on OK. So we come here, we paste it, and we need to put our borders here so that they will look good. And as you can see here, the intercept is giving you the coefficient of the respective countries: Ghana, Morocco, this is Kenya, you have Uganda, and then we need to interpret it. You can see this one is the coefficients of Ghana and statistically significant. It shows that it has a positive impact, and you can see the coefficients are not changing. The coefficient of trade openness and FDI still remains, because we know that the trade openness is negative and then the FDI is positive. This is how you can also know about the intercept of the respective country. You can also estimate the dynamic model here as well, and this follows the same logic. Go to model, you go to panel, so you can see here dynamic panel model, and I can choose to leave these things out. So first of all, you go here, you put your dependent variable, you remove these ones, and then you need the one step. So I'll click on OK, and as you can see here in the panel, the GDP is significant, trade openness is negative but not significant, and FDI is statistically significant, which is a positive. So this is going to be the panel. So you can also copy and paste it. Copy and paste it. This is going to be your panel. So you can paste it here and add these ones. I know this is going to be one step dynamic panel model, so I will just estimate it. We have estimated this one, so you can also close this one since we have estimated it. And let's go back to the model estimation for the random, which is our final model. So we have the random here. I'll put, and so we have the, let me choose random. Oh, okay. The constant must come because we didn't include the constant because we're estimating the random effect model. So this is the constant has to come when you're estimating this model. So we need trade openness and we need FDI. So you click on OK. Now once we have this, we can also access our graphs here. We have graphs. We can plot the fitted values against the observation number always. So this is how it's going to look like. You can also change this one. You can edit it, and instead of these ones, you can also use lines and the same format. You can also use lines and points, same format. So reduce this one and apply. As you can see here, you can see now it changed it, showing the fitted against the observation number. So this is how you can also check a graph. After you do the estimation, you can close it. You can go to this place again. You can also plot the QQ plot, and it's showing you this output. So this is what you have for the QQ plot. And you can also do another test here, normality. As you can see, it's greater than 5%. It shows that the errors are normally distributed. So that is all about the panel model estimation, and in the upcoming videos we will try and do distributed lag models, which you have a lag value of the independent variables in the model. We will also try the dynamic model, not dynamic panel. We will try dynamic model in the upcoming videos. Thank you very much for your time, and that is all for today.